Hello, and welcome to Lesson 3 of Learning Python. Today I'm going to get into some serious information about Python, and we're going to cover a lot of basic material that's important. If you've read my Patreon page, link below in the description, you'll have already read the prelude to this lesson where I go through talking about various terms and descriptions that will make this lesson a little easier. It's not required that you read the content, but it does help when I start throwing terms around in that you know what I'm talking about. For example, one common term that's used in programming is an iterator or iteration, which simply means counting items or a group of items. But an iterator is a special way of referencing a particular part of programming, which we are going to be demonstrating, if not in this lesson, then within the next few lessons coming. But today I want to focus on taking lesson 2 to the next step, getting some basic building blocks down within the language where we can really begin to start seeing the language come together. Lessons 1 and lessons 2 were very basic information. Now we're getting into the actual language components themselves. So first, let's start by copying lesson 2 to lesson 3. Now I could just magically pop up the lesson completed on a screen, but I don't believe that's beneficial for you. In my 30 years of teaching, I found that by typing the lesson out on the screen as I'm working through it, actually provides more information to you listening to the lesson and watching it and trying it on your own than just me splashing it on a screen. For one thing, you get to see my mistakes. Particularly, even after 30 years of being a teacher and a programmer, I still can't talk and type at the same time without making mistakes, either in getting my words backwards or in getting my typing backwards, or both. So it brings a certain level of realism to the lesson that you will see in your own programming. You're not going to be perfect when you type out your programs. You're going to have simple, stupid typing mistakes along the way. And if you use different environments like I do with different keyboards, it's only going to be that much more frustrating, but still part of the process. So I personally find that typing real time as I'm going is the best way to proceed. So let's actually bring up our editor, go into lesson 3. Okay, now let's recap what we're doing. Well, we've got the closing price, and we've got a floating point number, or just a number with a decimal, based upon the input that we ask the user. We've done that again for the risk amount. And now we do some mathematics and some output. We also ask the user for a buy amount. And then we calculate risk versus reward. Nice and simple. Let's run it. Okay. Whoops. What happened? Very simple. What happened is I just pressed enter. The program can't deal with a mistake. And that's a problem when we start trading. When we start dealing with real world circumstances where your program is constantly asking your exchange for information, sometimes your exchange is not going to give it an answer. Your program needs to be able to deal with that and actually have the exchange give the answer by going back and asking it again. So that's what we need to do. We need to find a way of correcting for these kinds of mistakes. We need to know that the program can function even when mistakes take place internally. So we know what lesson 2 looked like. Now we need to find out what really happens when you press the enter key after the input command. Well, Python has a neat little trick up its sleeve, and that is the Python Interactive Interpreter. You just type Python 3 and you can bring it up. Now we can do stupid little things that actually let us see what happens for certain commands. For example, A equals 5, B equals 7. Now what happens if I put A plus B? Am I going to get the number 12? No, because 5 and 7 are strings. They're inside quotation marks. Remember lesson 1. That's why we need to use the float command to convert the string to a number. So that's why lesson 2, we have the float around the input, because the input is always going to be a string. But what happens if there's no input? For example, we see value error, could not convert string to float. And then it gives a couple of single quotations, or what's called an empty string. Well, let's see what happens. What do we actually get back if we don't have something put in? Let's just put a simple string. And in Python, a double quote or a single quote can be used as long as you use them together. Test. Okay, I'm just going to put, and now if I see T, it says blah. Now, see where it has a single quote in the beginning and a single quote in the end. It could be a double quote in the beginning or a double quote in the end. Excuse me, and, not or. As long as you're consistent, you can use either one, and you'll see cases where you actually use both. And Python actually knows the difference. For example, let's come back up here. Let's replace it with the single quote. The single quote in this context is identical to the double quote used above. Now, let's actually see what we get if we just press the enter key. Let's display T, and we get an empty string. this empty string could also be expressed as double quotes. And it is the same thing, and Python sees the same thing because it folds it into just a single quote. So now that we know what the input gives us, now we can test for it. But we have to have a way of repeating the question if we get an empty answer. Okay, let's get out of the interpreter and get back into the code. So now let's come up here, and now we need to do a little bit of separation. Remember what I said from lesson 2. Sometimes not compounding everything is better. So first we need to set a variable. Actually, we're going to do an easy way. Let's go an easier way for now. Let's take this line and copy it. And now we're going to take it apart. So we know an empty string is simply 2 single quotes or 2 double quotes back to back. So let's take, I'm going to make an answer equals an empty string. Now we're going to use Python's special command to test. Okay, so here we are. While answer equals, but in Python, a single equal is an assignment. You're telling answer to equal an empty string. Here you're saying if answer equals an empty string, if answer is an empty string. This is a conditional, or simply a condition. So if answer is the condition of an empty string, which it is because that's what we said answer was from the beginning. So now we convert this over to just a simple string. Now, answer equals input. What is the closing price? So, as long as answer is nothing, then it will simply ask the question again. But while we're on the while statement, this colon is part of the process. This colon tells Python that we are done with our conditions, and we can have more than one condition. For example, we could have while answer is equal to an empty string and answer is not equal to a number, and we'll get to that shortly. But for now, while answer is equal to an empty string, just ask the question over. Now we don't need this part. This part is already done. So now all we need is just to convert the answer into a number with a decimal point. And if everything works properly when we run the program, when I press enter, I will just get the question back. Let's see if that actually works. What is the closing price? And there it is. So the closing price is $19,000. And it went on. So as you can see, it went forward. Now if you press Control C, you'll stop the program, which is fine. We want to do that right now. Let's run it again. What is the closing price? Okay. Let's just put a word in there. And we have an error. We have an error because it wants a number and we gave it a word. We gave it a string. So we need to also make sure that what the user gives us is a number. So let's go back in and remember what I mentioned just a few minutes ago. And not type a special word Actually, let's do this a little easier, or a little different for now. And type not equal float. So, we know what the answer is. Now we need to find out, is the answer a number with a decimal? Well, let's see what that means. Let's go back to our Python interpreter. Let's just set up a test. A equals 5. Now, type A. A is an integer. Now let's set A equal to 5.3. And let's ask again. So as you can see, numbers without decimals are integers. Numbers with decimals are floats. So if we type in 5 or just 19,000, the program won't work, or at least it shouldn't. But Python does do a lot of things that makes life easier for the programmer. So we'll see. We might be surprised. But now that we know through a special word that we can tell what the user gave us. That is, we can tell the type of what he gave. So let's go back to the editor. So if type not equals float, and it's an empty string, and that really shouldn't be an and, that should be an or. Why? Because that's like saying it has to be an empty string and not a float. Well, it can be both, but we want to test two different conditions. One, we want to test that it's an empty string, but we also want to test that it is not a float. So if it's an empty string or it's not a float, then we ask the question again. Let's see how that actually works. Let's go back into the interpreter. Now let's have answer equals an empty string. Okay, so now if we type the condition here, what's it going to give us? Remember, we want the language to test the condition That's why we have double equal marks. And result, or a Boolean expression, is true. Answer is an empty string. Now, let's check the second point. Type answer not equal float. So our condition is answer not equal to a float. That's also true. So an empty string is not a float. Now, what happens if we put these two together? Let's do answer, testing it for an empty string, and type not equal. Will it work? It does. But what happens if we do or? Also works. Now, what happens if answer is a word? Will it still work? No, it won't. Because you can't have both conditions at the same time. That is, answer being an empty string and a float. It can be one or the other, but not both. So if we come here, we see that the condition is true, that it's not a float, but it's not an empty string. So we need to ask the question again. In computer terms, this is called logic. And or not are typical logic words. A double equal sign is a comparative. Then you have not equal, you have greater than, less than, greater than, equal. For example, 5 greater than equal to 4 is true. 5 is greater than or equal to 4. But 5 greater than 4 is also true. But 5 less than 4 is false. These are Booleans or conditions. And in programming, this is how you get the program to actually act based upon the information it's given. So let's get out of this and go back to our editor. And we see now why or is so important. Because we have two different conditions that can't happen at the same time. So let's actually run it. Okay, what is the price? Let's do, okay, nothing, nothing, nothing. Why nothing? Because it's an integer. The program explicitly wants a float. We need to fix that. Now, we already know from the testing that there's another way of doing that. Or type answer not equals int. And actually here, for this part, we need an and. So if it's not a float and it's not an int, then get the question again. But because we are dealing with a compound logic, that is, it could be an empty answer or not a float and not an int. Now, the point of this, even though this is actually a little complex, it's not when you talk your way through it the way I'm doing it for the lesson. It really makes a lot of sense. You want to be able to accept a number without a decimal point, and you want to be able to accept a number with a decimal point, but you don't want an empty answer. So here we go. So let's go back and actually try this again. Now let's check the string. Okay. And it still didn't work. Why? Something's wrong. Let's find out. Let's go back to Python 3. Now, let's do a equals 9, 1, 2, 3, and let's test explicitly the condition of int and float. Maybe we do need an OR. Let's see. So type of A not equals float. Or, actually let's do what we have, and type of A not equals int is false. Okay, so if it's, so that's true. That's what we want. That is, it must be a float or an int. So not equals a float or not equals an int or an integer is what we want. But how do we write this in the condition so that we get this number to be accepted even if one part of this is not true? Again, we walk our way through the steps, talk our way through the logic as we're building the components. So if it's an integer or it's a float, then we accept the answer as valid. There is an easy way, and we're going to break it down. See, sometimes when you're dealing with conditions, your conditions need to be thought about in simple ways. This is what happens if you try to combine too much too early. Sometimes things don't work out. So, let's simplify this. And we're going to do so in a way that uses a variable to keep track. Actually, now, false is a special word. As we saw within the interpreter, when we do a condition, it gives an answer of true or false. The F is capital, and that is part of the language. So, we automatically set up the following process. So, while not done. Now, you can also say while done not equal true. But that gets confusing. While not done. So while we don't have the results we want, we keep asking the question. And sometimes we simply need to rethink about the question to make it easier to answer. Logic can be complicated, and when you're beginning, logic has to be careful. Don't try to get cutesy or gimmicky with your program, because it oftentimes doesn't work. So now let's look at this. If answer not equals an empty string, or actually we need and type of answer is a float, or type of answer is an int. So if it's not an empty string and answer is a floating point number or an integer, then done is true. Then our conditions are met. Then we can see we have fulfilled the situation. We will get a non-empty answer, and we will get either a floating point number or an integer. And the if statement, this is how you compare conditions. This is how you test what you want the program to do. Now, in this case, like the while statement, you'll see that the line ends with a colon. Python uses the colon for a lot of different things, but for special circumstances only. Now we have one more thing we're going to get into here. What if we want to be a little more specific? What if we want to tell the user what we're looking at? Well, we can do that too. Else print enter a number. And here we are. Now, here's something I'm going to highlight while we're here. You'll see that this section of code has been indented with the tab key. Python calls these blocks, and blocks of code all work by the command that is above them. So all of that code is connected to that one while statement. So while not done, these 5 lines of code will be executed. This is how you get things to repeat consistently. So let's see if this works. And hopefully we don't have any typos. Okay. Enter a number, an empty string. Enter a number. Okay. Didn't work. Why? What are we missing? Let's find out. So A equals 9, 1, 2, 3. Type A equals int. It's true. Okay, so int is true. If I try float, it should be false. So what are we missing? Let's go back and double check it. let's look at our expression. So if it's not an empty answer, so if answer not empty string, and type of answer is a float or type of answer is an int. That looks correct, doesn't it? But the program says it's not. Okay, let's try something else. It clearly says it's a float. So let's test it. Okay, that's true. Let's run the program and give it a float and see if the program works. Maybe we have to break it down more. Yep. So even though we have the logic right, we have to break it down more. And that is literally what we have to do through each stage of it. Okay, so we now know we need to break it down. So I'm going to use my editor and I'm going to copy this line. And let's see how we break this down. Okay, actually, let's try something different. What happens if we just test for number being either a float or an integer? What do you think will happen? Will it automatically reject an empty string because we're explicitly looking for a float or an integer? Let's see. Let's see what happens. Okay, let's put a string in. Still works. It still works. And it still does not work. Have you figured it out yet? Remember lesson 2. Actually, we need to do this differently. What was lesson 2? This works, but answer is a string. So before we can test that it's a number, after we test that it's not an empty string, we have to convert it. So first, let's check that answer not equal empty string. Now, we need to check, okay, now that we know it's not equal to an empty string, now we need to convert answer to a float. You see, remember from lesson 2, and actually lesson 1, when you use the input command, you automatically get a string of characters. So no matter what, you've got to convert the string first. So now, let's see if this works. It doesn't. Because again, it knows. It knows that even though we gave it a string, it's not a float. Now, the point of this little exercise is to help you understand that as you're working with your problems, you need to be able to see that the problem itself may not be conceptually what you think it is. In this case, our answer isn't directly the problem we want to solve, but being stuck here means we're not moving forward until we help the machine understand what we want. That is the problem of programming. And in the context of trading, what we see on the screen and what we think should happen really doesn't. What does happen is what is going on back here. What you see me going through trying to get this simple little process done. It's simple in the mind. To the computer, it's not simple. To the computer, it's difficult. So now we have the first test. If type, let's keep going to see if we can work this out. We need to actually work our way through the problem. But the problem is not what we're trying to solve. The problem is what the computer is trying to solve for us to get our answer. Okay, so if type is a float, then we know that we can convert it. Now, what if type isn't a float? Well, we can use another Python command. Else if type what if type is an integer? Well, then we need to answer into an integer. And we are done with the loop. We are done with the while statement if either of these conditions are true. Otherwise, we keep asking for a number. When you're first learning and you're trying to think about the problems you solve, remember that you have to think about the problem the way the computer sees the problem. So in our case, the problem is we want a number. That number can be with or without a decimal place, but we need a number. If somebody puts something in that's not a number, then we have a problem. And we need to make sure we get that number. So let's see if this works. So let's try again. That part works. That part works. But notice we didn't get a message. We didn't get the enter a number when we gave it hello. That could be a problem. And that still didn't work. So we're still missing logic. Our attempt at understanding the problem isn't working right. So now that we have our problem, and we still can't work our way through logic, let's think about the problem. The problem is simple. We don't know what the machine is actually giving us. We think we know, but we don't. So let's actually find out what the machine is giving us. Our good old friend, print, will tell us. We're going to print the answer, and we're going to print the type of the answer. Because even though we think we know what's going on, something's not working right. So let's find out what that is. So let's run the lesson again. And it says we gave it a string. But the Python interpreter says that when we tried it, that it was actually an int. So how do we console the two differences? Well, Python actually does have a way. But what did we learn in this little experiment? We learned that no matter what you give input, it will always be a string. Even when it is just a set of numbers, it will always be a string. So trying to get the type of an input will always cause that problem. But now when we're getting information back from the exchange, that may or may not happen, but it's still something to be aware of as we progress in learning. So we know beyond a reasonable doubt that the blank string part works. But now we need to use another aspect of Python. We need to look at what happens if we deliberately force an error. So we need to simply try. Again, another special Python command, providing I type it right. We need to try to convert the answer into a number. And in Python, if we succeed, we're done with the loop. Otherwise, we have an error, and we're just going to go real simple right now. Later on, we're going to expand this into a much broader context. But for now, we're just going to simply put we're going to tell the user to enter a number. So if the answer is not a blank string or an empty string, let's try to convert the number into a decimal system, or the string that input gives us. We need to brute force try it. What's going to happen? And let's try. First, let's give it a string, enter a number. A blank works. It worked. By that brute force approach of just trying it and then telling Python to catch the mistake if it happens, and to simply put enter a number, we were able to logically work through the process in a way that Python understood the problem. So from the standpoint of what we just did, we solved our first major problem. We actually took the input from the user and we made sure the user gave us a number. But before we could work through and actually come up with the answer, we had to find out what was the machine actually wanting. When you're programming, what you think is going on isn't what actually is going on. A lot of things happen from the point of you typing the numbers in to the point that the machine can actually use the number as a number. And that can get complicated and confusing. Now mind you, we ask for 3 numbers here. That means we actually have to do that whole process 3 times. Now there's another way of doing that, where we can actually use that process 3 times, but only typing it once. And that's called a function. Some languages will say procedure, so forth, but Python is called a function. So let's actually go back into the lesson and let's take this section right here. This section, we either have to make this section 2 other times, or we have to turn it into a way that we can simply refer to it. That is, extend the language. How do we tell Python this is what we want, but we don't want to type this out 3 times? There's a way. And this is kind of what I warned about in the prelude to this lesson. This lesson is going to be very difficult in some respects because there's a lot of context you need right away to really begin to use the language. So this is going to probably be one of the more beefier lessons. But let's take a special word, define. We're going to define a function, and we want to call that function get user input. Now, we need this function to display a string or to ask a question. The user needs to know what we want. So with parentheses, we are going to ask for the question. So from the standpoint of you writing this program, when you use this function, you are going to give this function the question you want it to give the user. And like the if statement, the try statement, and the while statement, the define statement is a special situation that requires a colon. So now that we have this, we're going to simplify this whole process. Very simply put, we want closing price to equal get user input, and then we want the machine to ask the user this question. Now I'm just copying this so I don't have to retype it. So there we are. The closing price will be get user input. What is the closing price? Now we take this whole section and we move it up here into our function. Now we're not done yet. Because we're under a function, we have to indent. That's just a matter of pushing everything over so that the function is the priority. That is, the function is the block of code we are working on. This block of code. Now, there's one more thing we need. We need to return the floating point number. So we want this function to return to the user. Of course, we need to spell it right. The answer of the question. So this function will ask the user the question, wait for the user to give them the answer, make sure the user gives them the right type of answer. That being, we need a number. If all that takes place properly, then this function will return the answer to our variable of closing price. So now we do the same thing down here. That is, we reuse what we have above. So get user input, we ask the question, and then we convert it into a percentage. And we, same thing, get user input, now check your parentheses. Make sure you always check your code, because like right here, we forgot to take this parentheses out. If we run it, it'll give us an error when it gets to this point. But we see it, we know it, we take it out, and it should work. Save your work frequently. So now we've actually taken, instead of typing this section of code 3 times, we're actually taking this section and reusing it 3 times. We've made our code more readable. We've made our code more functional, because we have taken a process of actually solving the problem the computer needed solving, but in turn, it solved the problem we wanted solving. So let's see how this works out. Let's save it. Let's run it again. Okay, let's enter. Okay. Didn't work. What did we do wrong? Or did it? It did. I just blind as a bat. Let's try that again. What's going on here? It's not giving us new closing questions. What did we do wrong? Well, that's because we didn't change the question. Do you see the problem? We gave the question we wanted to the function, but we didn't actually use the question we wanted to the function. Now, it will give us the question we give it. Let's try that again. Oops. Okay, there's the question. 19,000.5. Now, we get the second question, the way we wanted it. Now we get the third question, the way we want it. As you can see, a lot of little mistakes can be frustrating. And this is why it's important not to let yourself get overwhelmed. Programming can be very overwhelming, especially at this stage when this video, for example, presents a lot of critical components that you need to really get down to be able to move to the next step. So let's really recap this. Very simply put, in Python, certain things require special symbols. If, while, try, except, else, and define. Those are things that you do have to remember, but as you use the language, you'll remember them automatically. The while statement lets you check a condition to determine if it should or should not continue a particular set of code or a block. All conditions are either true or false. So while and if always test conditions. If requires special circumstances for the condition if it's equal to, meaning you need double equal signs. Functions, as what you see here, are designed to be reusable. They're designed so that you can use the same function multiple times in multiple situations, but it giving different results as you go. In the case of this function, we don't want a blank line or an empty string, but we have to have a floating point number. So this function makes sure the user gives us that information. If the user doesn't, then it simply tells the user to enter a number, and it keeps doing that until it gets the answer it needs. As we progress forward, this kind of a function will be critical when we talk to the exchange, because a lot of times the exchange is not going to give us the answer we need, and we have to retry until we get the answer or until we just give up after a certain amount of times. But this is the basic structure of how you set that up. But as you can see, when we're actually using this part, your code is readable. It makes sense. Closing price is get from the user and ask him this question. That makes sense. You can read that and understand it. When you're using your variables and you're giving your function names, that is how you make your code readable. 1 month from now, 6 months from now, you will be able to read this simply. Same thing down here. Get the user's input, ask him the question, and convert it into a percentage that we'll call risk. Now here, what if we want a different number for reward? Well, we already have the framework. Let's take this, get rid of it. Now, let's get the user's response. We're actually just going to copy this and make a few changes. Okay, we got to get the highlight right. Now, let's take and copy this. Turn off the highlight. Now, we have the reward percentage. But this is not a percentage. This is a ratio. And that ratio is multiplied by the risk. So our reward is going to be 2, 3, or 5 times our risk. But as you can see, we're reusing the function we made above in a new way. Let's see how this works. Save the work. Okay, closing price. Let's do 23,000. Risk percentage. We want to risk 1.5%. Reward ratio. I want a 3-to-1 reward to risk ratio. Okay, there's our take profit, there's our stop loss. Now, let's do a $15 position size. And we have the numbers. Now, there's still more work to do. For example, profit and loss. That really needs to be cleaned up and fixed. Those numbers are just weird. But that is just visual from the standpoint of what we tried to achieve. We did it. The program worked well and gave us the numbers we wanted. So we were able to take what we wanted through experimentation and understanding what the machine was wanting. Take our ideal and break it down into steps that the machine could understand. From there, by doing that, the machine was able to complete what our objective was, which is to give us the winning position and the losing position amount, along with the take profit and stop loss, what we wrote this program for. Now, it took a long time to get here, but that is the point of programming. What you see is not what the machine sees. You have to think like the machine. The machine can't handle complex thinking until you tell it how to. And that is exactly what we did with our function. We told the machine how to get an answer from the user, but to make sure we got the answer we needed, which was a number. Now, this lesson is probably one of the more complex ones in the beginning, but as you begin to build further on with the other lessons, this one will become second nature, and you'll just understand it. But there's a lot here. There's a lot of special commands. So I encourage you to re-watch it several times, take notes, understand each point of it, and ask questions. Leave comments below. Let me know if you have a question or if you're confused on a part of the program. Put this in, type it out, run it. Make sure you actually see how well it does. So here's the top of it, the stuff that we copied out of other programs. Here's the entire get user input function that takes the question and asks the question to the user and then waits for their response. Pause the video if you need to have time to type in this information. Remember that you get these gaps by pressing the tab key. My tab is set to 4 characters, which is the standard in most Python programming. It makes it readable, and it's required by Python to have some indentation between each block. For example, here, the first block is the definition itself. The second block is what's given to the while command. The third block is what's given to the if command. And you see that the try except else command has 3 blocks in it. And we will go through more of what some of these mean. But basically, try this situation. If this situation works, we are done. Try. If it works, else done. If it doesn't work, accept and give me a message. Print an error. Do something that tells me I did it wrong. So try to brute force it. Did it work? The exception, it didn't work. We screwed up. Do it again. Otherwise, or else, it worked. We're done. The condition we need succeeded. While not done, while not getting the answer we want, repeat this block of code until we do get the answer we want. And this part here tells the system explicitly we have the answer we want. Once we have the answer, we've got to give it back to the other part of the program. We just can't keep the answer to ourselves. We've got to give it back to the program so that it knows it's got what it needs. Now it can go to the next step. And then we go and we ask for the risk percentage. Then we ask for the reward ratio. Then we calculate our stop loss and our take profit based upon risk versus reward. Then we tell the user what the closing price is, what we calculated for the take profit, what we calculated for the stop loss, and we ask them how much they want to buy. Based upon their position size, we tell them how much they'll win and how much they'll lose, depending upon whether they're right or wrong in how the trade goes, meaning which way the market will go. If the market goes the direction they want, tell them what their winning position will be. If the market goes against them, tell them how much money they'll lose. And that is literally the entire program. It may take 2 or 3 times watching this video. Be sure you read the Patreon articles, as they can often make a lot of this technical jargon easier, plus provide little tidbits. But most importantly, type this in yourself. Actually, physically type it in and try it. What happens if you make changes? Take the knowledge you've learned here and grow from it. Programming is not something you can just watch and absorb. In order to learn programming, you have to write the program. Leave a comment. Let me know any questions you have. Like, share, subscribe. Join the Patreon in the description if you're not already. And until next time.